Greetings to you. Some of us have found problems with solving some of the integration, but today I want us to look at one of the best methods that we can use to integrate such a number given to us. First of all, what you should put in your mind when you find a number like this one, integrate the x out of the exponential of x minus 1. This integral of ours does not have limits, so when you're integrating, you should have that in mind, that the integration I'm dealing with has no limits. Okay? So what do we do instead? What we do, we first look at the integral, we classify it into the types of integration and the types of methods we use to integrate certain numbers. And when you look at this one very well, you realize that before you use any other method, you may require to use substitution so that you can eliminate the element of the exponent power x minus 1. How do we do this? Let us see. In our solution, we shall say that the integral, first of all, we shall start by substitution method as I have told you. So we shall be moving from one parameter x and we shall be going into any other parameter. And this is our choice. You can take any choice of any parameter that you want in case you're integrating. And today I will choose to use a parameter p. We shall let, in our solution, we shall start by letting the parameter p to the power x minus 1. But when you look at this one, you know that by all means you're having something to substitute. So you need to substitute the value of the exponent of x alone. This one also will imply that as exponent of x alone will be p plus 1. I hope we are together with that. Okay. Having seen that, we have replaced this one and we are able to substitute, but we also need to substitute for what we call the derivative of x into the derivative of p. How shall we do this? We shall do this by differentiating both sides here. I say the p over the x, this one equals to exponent of x. When you differentiate the exponent of x, what happens? You know that when we are differentiating, we shall drop the power here. When you differentiate this x here, differentiate x, you will get 1 times the whole thing that remains. That is according to the laws of differentiating exponential functions. We shall have e power x minus. But we know all of us that when we differentiate number 1, we differentiate any constant, we get 0, and we can see that 1 is really a constant, and therefore we shall have a 0. So we shall have nothing. This one just be our x. So we shall need to also make the subject of the formula because we want to replace the x by the p. This one will clearly imply that our dx is equal to 1 out of e power x d e power x dp. I hope this makes sense, right? So, what shall we do next? What we shall do next is to substitute the values of dx and the values of e power x that we have substituted in this integral. And therefore we shall have our integral from x e power x minus 1 is going to be the same as the integral. We are now going to substitute for this one here is 1 out of e power negative x, but e power negative x minus 1 we have seen as being characterized by parameter p. So we shall have 1 out of p, 1 out of p, and then we now need to replace the x, the derivative of x we have gotten is this one, that is 1 out of exponent x times dp. So here we have an integral which is clearly in a parameter p, and we have managed to substitute the parameter. We have managed to substitute the parameter to remove x and put p. So what do we realize here? We realize that we still have the parameter, but we wanted to completely remove that parameter. That's why at first we had to improvise for what e power x was. From here, we see e power x is equal to p plus 1. So here this one will give us the integral 1 out of p plus 1 out of p plus 1 dp. And here we shall be able to apply another term which we all know and we call it the famous partial fraction. How do we break this one into partial fractions? Breaking means that we need to get two parts because it is one part, and we shall use the method of partial fractions to break this one. And we shall leave this one first of all at that level, and we shall come here and say but 1 out of p into p plus 1, this value is supposed to be equivalent to any constant out of p plus another constant p out of p plus 1. Simply because here we are having a linear function. P is a linear function or a linear polynomial, and this one here is also a polynomial which is linear, that is having a degree 1. That is why here up we put constants without anything. These things do vary in case we are having like a quadratic equation, so they will be variable. But since here we are having just linear polynomials, we can just have constants a and b. So we need to solve this value. So here we shall have 1 is equal to a times p plus 1 plus b minus p. And now we shall be testing for different values of p. When p is equal to 0, when the value of p becomes 0, within this equation here, realize that when we multiply through putting the value of p is equal to 0, we shall have 1 is equal to p plus 1, but p is 0, so we have 0 plus 1, which is 1. 1 times a, we shall have a, and p times 0, which is the value of p, times b, we shall have nothing. We have gotten the value a, which we shall replace here. So we also need to get the value of b, this constant here. So we shall again come and do the same thing we did here by assuming a certain value of p. We can now come here and say, we shall now say, when p is, for example, when you are doing this thing, you have to be, of course, creative. You know what you have to eliminate. For example, I'll be interested in eliminating the value of a. So which value here can I replace with p so that I can have the value of a, all of it going to 0. So when you look at this one, literally, if you put the value of p equaling to minus 1, it means that your function here will be 1 is equal to a into negative 1 plus 1 plus b, b times the value negative 1. Clearly, since this one is a plus, we shall have negative 1 plus 1, which will go to 0. And we shall have this thing going to 0, and we shall remain with the negative b. This one clearly implies that the value of b will be negative 1. Having obtained that, we shall still come back and replace the values of a and b into this equation here. This will mean that 1 out of p into p plus 1 is equal to 1, because we have gotten the value of a equal to 1, so we shall have 1 out of p plus this value positive p, but we got the value of p as negative. So it would make more sense if we just say minus 1 out of p plus 1, which is p plus 1. Now from this sense, we see that this is the value we are integrating from the start, which was this one. So we can again bring back our integrals back. So that the integral from 1 out of p into p plus 1, the key is going to be, we also distribute this integral on this value and that value. This is going to be 1 out of p dp minus integral 1 out of p plus 1 dp. Okay, and I'm sure that we all know very well, we looked at this one, that when we integrate 1 out of p, we shall come up with the natural logarithm, what we call the mean of p minus the mean of p plus 1. Okay, in our conclusion, we can still, but of course, having written this, we realize that now we have moved already from the integral. But since our integral from the start did not have the value of the limits, we need to cater for different what? Different variations of different methods. That is why we can come and add plus c. This is meaning a constant. Looking at all that range, all that area of values that will be put, depending on what will be put as the limits of the integral. But we didn't have p at the start? Of course not. Therefore, we cannot give the parameter p, but we have to rather come back and see what was the value of p. And the value of p was exponent x minus 1. So we shall simply replace. This is going to give us, the lid of exponent x minus 1 minus the lid of exponent x minus 1, but plus the one. We are adding this one because our p alone is exponent x minus 1, without forgetting the value of constant c. This one will clearly give us the lid e power x minus 1 minus the lid of e power x plus c, which we shall at the end say lid of e power x minus 1 out of e power x plus a constant. And we are done. That is what we wanted. Thank you for watching. See you in the next lesson.